Yeah, thanks for coming, everyone. Super excited to be here. Thanks for Paradigm for hosting this event. We're going to talk about two programming languages today. Any guesses? Which ones? What's that? Rust is one of them, not JavaScript. JavaScript is like no one really likes it. We're actually going to talk about TypeScript, which is like, a little different. And if you're not familiar with TypeScript, it's a superset of JavaScript. It actually has a really important role in the crypto community. Everything from Uniswap, ENS, Friendtech, if you've used any of these things, they have front ends, which are primary ways that people interact with protocols and other really cool stuff we build. And I just so happen to maintain a couple open source libraries. One of them is Wagmi, which is a higher level React hooks library. If you've donated to the latest Gitcoin round, you've used Friendtech, you've registered a domain on ENS, anything like that, you've probably used Wagmi. It's pretty popular throughout the space, allows you to do stuff like connect wallets, send transactions. And yeah, it launched fairly recently and it's sort of taken over the front end world. Me and then my co-collaborator, Jake, who's in Australia, so he couldn't make it, started collaborating with Paradigm in November last year. And yeah, just some examples of what you can do. Here's really simple way to connect a wallet. You would think that this is easy, but there's so many different wallets out there, hardware, like lots of other ones. And if you do a little bit of configuration in Wagmi and then just put this code into your editor, you end up with something that doesn't look quite as nice as that because you have to write CSS, which is kind of a disaster. But yeah. And then you can do other stuff too, like contract interaction. Here's an example from mint.fun, just like minting NFTs. Pretty straightforward, not a lot of code. And so we had this higher level reactive framework to build applications, but we wanted to move a little bit further down the stack. And so, there's things like this that have existed over the years, Web3.js, Ethers.js, and I feel like similarly to the rewrite it in Rust mentality, we were sort of rewrite it in TypeScript, really, really good type safety and type inference. And so Viem, which is our effort for that, launched earlier this year. It's a lower level interface, does JSON RPC requests, ABI encoding and decoding, signing. It's kind of a cool thing to do because Wagmi was originally written in Ethers.js. We wrote Viem, swapped out the underlying implementation. Everything kept chugging along on all the dApps and stuff that were using it. And so Viem's, we rewrote it. It's pretty fast. This isn't, probably what you would see, if you compared Rust with these different JavaScript frameworks. But in terms of encoding, it's the fastest out there that I'm aware of right now that's used and very popular. And it does some cool stuff. You can interact with Anvil really easily. There's wrappers for all the Anvil methods you could use, and this is really popular and people using it in their front end, test suites and stuff like that. This is the part that I get really excited about. So basically, everything up until this point has mostly probably just looked like JavaScript to you guys, because it is. TypeScript is superset of JavaScript. And there's this really cool thing that you can do. TypeScript is a Turing-complete language, and what you can do is you can take code. So in this case, here we have an ABI fragment, which is a tuple, and then in the TypeScript type system, you can transform it and then create static types, which then add a lot of nice type safety, whereas JavaScript doesn't have any. And this is really important because if you pass the wrong number value, or you're not passing an address or something, people might lose money, something might break. It's not a great situation to be in. So here's an example. We have this ABI fragment, and yeah, you see a type error here because we've parsed that in the type system and then pulled it out and said, okay, this needs to be a big int, and because it's not, it's throwing an error. Big ints in JavaScript, this would have been 420 and then an n after it. And similar thing, we don't just do types, we do like, fixed length tuples too. So here's one. The type system is really cool and allows us to do some like pretty complex stuff. It's like a whole programming language in its own. And just to demonstrate something that I think is like even cooler, but demonstrates the power of TypeScript. This is like a function. We have human readable ABIs. This is a function called parse ABI, which takes, basically you can just copy the signatures from your contract. And it has two implementations. One at runtime, which will transform those strings into like a JSON ABI, but then also a parallel implementation at the type level, which in your editor you see I'm hovering over the symbol and it's transformed it, which was cool. So yeah, I think like one thing that we've been trying to hammer on a lot is this concept of like advanced developer experience, which coming from the Rust world, some of these things might look pretty similar, like making sure things are strongly typed, inferring types wherever we can. It's really nice to be able to just go into your editor and write some code and auto-complete your way to success. And yeah, we support ABIs, type data, schemas. The ABIs can be massive. If anyone has like a really large contract that they know of, you can tell me about it because I'd love to like try it out. But this stuff works really, really well. You can you can just throw massive contracts at it, and the type system's able to handle it all. Modular architecture. So we really care about making sure that all the functions that exist in Viem and Wagmi, are low level enough that you don't have to like do workarounds and things like that, and they're really composable and work well together. And then because often this stuff is running in the browser, some people are building their APIs with Viem and like other backend related stuff. But because a lot of this often runs in the browser, making sure that it's as small as possible. Yeah, and we try to make contributing easy. Wagmi, I think, has around 150 contributors. Viem has, I think, around like 80. And yeah, really high quality docs, tests, because that's the stuff that makes, that stuff can make your day job really painful if you're using library, and makes it easy for people to learn. I think reading the Viem docs has been really helpful for a lot of JavaScript people because it sort of introduced them to like lower level concepts in Ethereum that were abstracted away before, or they didn't really understand. We try to use the same names for stuff, like RPC methods map to, like those names map to exactly the same names in Viem for functions and stuff like that. And so yeah, the stuff we built has been pretty popular. Okay, so now for Rust, like writing TypeScript, there's some things that I am very envious of when I like look at the Rust world. Error handling JavaScript isn't the greatest. One of my personal favorites is like pattern matching in Rust. It's like really nice. I wish something like that existed. There's like libraries and stuff. I feel like the JavaScript community has like basically built libraries that are Rust language features. Package management is another. Random One Cargo is great. There's like 3 package managers at least that are popular for JavaScript. And then obviously performance. That's something whenever you're writing something makes you feel good about it. So this is where we get to maybe combining Rust and TypeScript together. This is kind of like a blue, like because TypeScript's blue, like Ferris cartoon version. And so something I've been thinking about is like how can you take some really great stuff, TypeScript types, and that's like the stuff that JavaScript developers are using in their editor and like keeping things safe, and how can you pair it with something like using Rust at runtime? Maybe there are some libraries and stuff that you're lazy and you don't want to re-implement that in JavaScript. Maybe they're really solid, lots of people use them, they're extremely performant, stuff like that. So yeah, this is just like an exploration into TypeScript and Rust via WebAssembly. Sort of the goal here was to see if we can maintain the same developer experience, but then also like maybe reduce some things like bundle size and improve performance like significantly, and also give JavaScript developers access to the Rust community because there's a lot of great stuff happening. Yeah, and you see the TypeScript logo here. It's not as great as Ferris, so unfortunate. Okay, so to set the stage, have a demo. It's going to be using Ethers RS. Unfortunately, I'm not familiar enough with Alloy to have implemented that. And yeah, Viem, and we're going to compare them together. So on the left-hand side is Ethers RS, and this is just going to be signing some data, which we'll look at in a sec. And then on the right is Viem. So yeah, I wonder which one's going to be faster. I mean, that's pretty fast, right? You know, not perceivable, but you know, it's Rust, so definitely quite a bit faster there. So what does this look like? If you wanted to do this for one of your libraries, how would you do it? So there's some imports and stuff that's not here, and excuse like my Rust if it's not, you know, something's a little funky with it here. So yeah, we're just signing some type data, so we're going to expose that method in a way that you know, Wasm can use, and then also we're going to be generating random wallet, so doing that as well. You know, if you're not doing any crazy type level programming, which we are, you know, in this case we are, you can just get TypeScript types to automatically work with this stuff without too much overhead. But in this case, we're going to like write some basic TypeScript using this library called ABI type, which is one that we also work on, which does a lot of the type transformations. And so, yeah, I mean, there's not much here. It's pretty straightforward. And yeah. And then in terms of what you have now, you run Wasm pack, and now you have this library that you can use. This is in JavaScript now. And you get all the benefits of Rust behind the scenes, and then you also get the benefits of TypeScript, really strong type safety, inference, auto-completion, and yeah, works really well. So, you know, what does the future of this look like? Wasm's been around for a while. No one's really used it. It's not like, I mean, it's not like a frequent thing that people are reaching for all the time. What are some reasons for that? Well, unless you're doing something extremely computationally expensive, where, you know, you're okay with like having some maybe context switching between different languages, and you're okay like going over the Wasm bridge and taking that hit, and then maybe loading some extra bundle size depending on what libraries you're using. Otherwise, you know, people have sort of stayed away. But some things that I'm excited about as stuff improves is maybe we can swap out some internals in Viem. Like we have our own ABI encoding, decoding in there, which is pretty fast, like you saw, but you know, it doesn't compare to Rust. You know, so if that becomes a bottleneck, eventually maybe we want to swap it out. Another thing that I think is really exciting is maybe running Anvil or something like it in the browser someday for simulation or other things like that. And then another thing, like, you know, I think it'd be cool if, for certain things that are applicable to like a wider audience, maybe people that would use JavaScript libraries, that, you know, there's implementations that already exist in Rust, is like adding TypeScript types and Wasm packing your Rust library. Because then you don't have to write, you know, that much JavaScript. You're only really writing the type level. And yeah, super down to chat about this more. I think it's exciting, and it will only get better if like there's some cross-pollination between communities and people are working on stuff. Especially in crypto, I think there's maybe some exciting use cases. So yeah, TypeScript loves Rust. So there's actually one more thing I wanted to chat about here, which is this thing called Rivet. I'm not sure if anyone's seen this, but we announced this morning. And Rivet is, so right now we find ourselves in this situation where, you know, as developers, most of us are using consumer wallets and like global test nets to write our software, which aren't really meant for this use case at this point. You know, consumer wallets don't necessarily have features that, you know, you need to debug stuff and iterate quickly. If anyone's tried to like do stuff like run Anvil and use MetaMask and have to reset nonces and stuff like that, it's not very fun to do. And then global public test nets, sometimes the iteration speed is slower. You have to deploy things. You have to scrounge up some testnet ETH and things like that. So yeah, the goal of what Rivet is what if we built, you know, some tools for developers to use. And so that's what Rivet is. It's developer wallet and dev tools. sort of like React DevTools, if you've used that, or any other browser dev tools. It's a little bit higher level, allows you to like manipulate state of Anvil, so you can like really shorten the feedback loop to doing stuff like send a transaction, okay, now it's reset. Need to like add some balance or fund an account, just click a button to do that. And yeah, we're super excited to collaborate with Paradigm on it. You can just go to this link if you want to try it out. It's in like an early alpha state, and I'm going to show it to you here in this demo. So we're on Uniswap. This is the Uniswap's website. We can connect to it. We can pick, some ETH amount, swap to USDC. The cool thing about this is, you go to any website, start interacting with it. In this case, we're not going to confirm the swap right away. We're going to change our balance so you can see how it works. We're going to auto mine or manually mine here. So we switched our balance to 10, and now we don't have enough. So everything's updated appropriately. So let's add some ETH back to our balance and mine that. And then let's switch to interval mining so we don't have to manually press stuff anymore. And then, yeah, we can just swap, and it's done once it comes up to confirm. Yeah, and so, yeah, we just swapped it. You can see the nonce incremented. We can see the transaction went through. And yeah, we're super excited to keep building on this and making sure that it's like really solid and something that shortens iteration time for people, allows people to collaborate. One thing that we're really excited for is this notion of time travel debugging, where you can just jump back and forth on the chain to reproduce issues that users are having, and just move really quickly. So yeah, that's Rivet. And if anyone has any questions, happy to answer them. Oh, and you can go to these links if you want to learn. Oh, you can go to these links if you want to learn more about our JavaScript, TypeScript.
We're going to do 2 questions for Tom.
Maybe you can't answer this, but why do you think the Ethereum Foundation isn't pushing forward a lot of these ideas? These ideas are excellent and badly needed. And how hard is it going to be to push these ideas back into the Ethereum Foundation, if at all? I wonder. Maybe you can't answer that, but.
Yeah, you mean stuff like developer tools or Rust? Yeah, I mean, I think the Ethereum Foundation's great. Like, they set up some roadmap and things like that, but Ethereum is like a community, so people are just working on stuff that they find cool and taking initiative. So yeah, how does it get back in there? I don't know. I feel like the community already does a decent job, but I think, yeah, sometimes it is good if stuff comes from like a respected, trusted source too. So I don't know.
And maybe to add on that the EF is responsible for fostering an ecosystem, but ideally the ecosystem, it should be anti-fragile. The EF should be able to disappear tomorrow, and the ecosystem should still move forward.
Thanks. I was curious, what's your experience with WASM and the maturity of it in terms of adoption in the browser a little bit more?
Yeah, I haven't used it a whole lot other than just experiments around it. So yeah, I guess that's mostly it. I mean, from what I've seen, just based on diving into it really quickly, it's like the developer experience of like me jumping in with no knowledge. There's a little bit of learning curve to figure out how to like package these things up. But once that's done, I can like this Wasm wallet package. You can go to npm; it's available there, or you can go to this website wasm-wallet.vercel.app and just try it out, and it works. It works pretty well. So stuff's definitely a lot better, than it was like 5 years ago when I tried to hack on it then.
And one last question from James.
In the same vein, have you done any like bundle size comparisons for the WASM versus Viem?
Yeah, so this specific case, the bundle size was actually increased a little bit, but there's a lot that you can do to try to like eliminate that. Yeah.
And I'm asking because in the past, like the reason I moved on from a lot of Wasm stuff is because the bundle size blew up, and like Webpack and the whole pipeline was not well suited to Wasm. So I have quite a bit of experience here. If you need help.
Totally. Yeah. Very interested.
Big applause for Tom.